Today, we're going to talk about reducing radicals. But first, let's think about what is a perfect square? What does that mean? So, a perfect square, if we start at the smallest ones, we have 4. We have 9. We have 16. We have 25. We have 36. And we have 49. What do these mean? Well, this is saying that this is just 2 times itself. And this is 3 times itself, 4 times itself, 5 times itself, 6 times itself, and 7 times itself. Well, when we're reducing radicals, we want to look at the radicals. Say we start with radical 12. We want to look at this number 12 and say, do we have any of these perfect squares? So these 4, 9, 16, 25, 36, 49. We want to say, do we have any of these in this number 12? Well, of course, these aren't all of the perfect squares. There's infinite many, but I like to start with the first few so we have something to look off and build off of. So 12, what goes into 12? Well, 12 is 1 times 12, but that doesn't really help us. 2 times 6. Are either of these perfect squares? No. So let's put an X there and let's put an X there. Let's see, 3 times 4. Well, I think this works. 4. So we can rewrite this as the square root of 3 times 4. Well, we know the only way to leave the house, the radical house that is by being a perfect square. So we can take this 4 out, but how must it leave as? Well, what is the square root of 4? 2. So this is going to leave, and let's rewrite it over here. Radical 12 equals the square root of 4, 2. But can the 3 leave? No, right? So the 3 is still stuck inside of the house. So this is how we would reduce radical 12. Well, let's say we want to look at something. Let's go a little bit harder. Let's step farther. Okay. Well, to practice that just a little bit more, say we have radical. Oh, that did not work so well. Let's try that again. Perfect. Let's say we have radical 75. What's the first thing that we see here? We see that 5. We know what this is. We know what goes into this. So we have the square root of what? What do we think? Well, we know that 25 goes into it, and that's our perfect square. So how many times? 3. So this 25 gets to leave the house as its perfect square, 5. And then that 3 is still stuck in there. So we can rewrite radical 75 as radical 5 times 3. What if it wasn't that easy? What if we were given radical, let's see. What if we were given radical 216? So this one looks a little harder. There's no 5 right here at the end. So we don't think that the 25 goes into it. We're not sure. I always like to start by writing our perfect squares along the side somewhere. So let's put them over here. We have 4. We have 9. We have 16. 25. 36. And 49. So again, there are plenty more, but I always like to start with just the beginning ones, because typically if one of these is going to go into it first. So 216 divided by 4. Let's look at that. 216 divided by 4. We get 54. Okay, perfect. So we know that this one definitely goes into it. Well, let's see if a bigger one goes into it. 216 divided by 9. Let's check that out. That becomes 24. All right, so see, we're getting smaller. So our goal is to have this be as small as possible and still be a whole number. Let's look at 16. 216 divided by 16. Let me get my calculator quickly. I can't do that one in my head. So that's 13.5. So that's not going to work. So we'll put a little X there. What about 216 divided by 25? Yeah, no, that one doesn't work. So that we're just going to put a little X in. What about 216 divided by 36? So this one equals 6. Well, looking at this number 6, we can see that there's only one number smaller than it as a perfect square, and it doesn't go into it. So it's a pretty safe bet that this 36 times 6 is going to be the biggest perfect square and the smallest answer. So let's put that in. So we know that 216 is the same as 36 times 6. Well, our 36 gets to leave the house as its perfect square. So this is the same as 6 radical 6. So I know it's a little complicated, but remember, we always want to start here. Start by listing out your perfect squares, and then start by checking all of them in that to see which work and which don't. Well, what if we had instead, if we had tried to divide 216 by 9? So instead of going all the way to 36, if we had said, well, 9 works, so let's do 216 radical that. Well, that's the same as 9 times 24. Okay, well, this would work. So the 9 comes out of the house, and we get 3 radical 24. But 24, well, let's look. Does 4 go into 24? Yeah. So this is the same as, let's see, there we go. 4 times 6. There we go. So 4 times 6, well, this radical, our 4 comes out as a 2, and then we're left with a radical 6, but we can't forget that we have this 3 up here, so we bring it on down, and we get 3 times 2, or just 6, root 6. So even if you didn't know right away, like, oh, I went all the way to 36, perfect. Even if you had stopped somewhere up here, it takes a couple more steps, but you're still going to get to the right answer down here. What if now we added in a variable? Well, what if we had, let's think. Okay, what if we had radical 125? Let's extend that radical, n squared. Well, let's look at this first, the 125. Well, we'll list this. We have 4, 9, 16, 25, 36, 49. I don't know about you guys, but I would instantly look at this, the 25, because of the 25. So we can see that this is the same as radical 5 times 25 n squared. Well, our 25 gets to leave the house as a 5. Then we're left with 5n squared. But this squared, this n squared, what happens? Well, it's just the opposite of the radical. So the square root of n squared is going to be just n. So we would get 5n radical 5. 5 as our answer. What if, though, it got even more complicated? Let's say we had radical 800 x cubed y squared. Let's look at each of these separately. So radical 800. Well, breaking this up, we can have radical 8 times 100. We know 100 can come out as 10. 10 radical 8. But can our 8 be reduced? Let's see. Well, think about our first perfect square. This is the same as 10 times radical 4 times 2. And our 4 gets to leave. So 10 times 2 root 2, or just 20 radical 2. So this 800 has been reduced to 20 radical 2. Well, what about if we have radical x cubed? Well, this is the same as radical x squared times x. And because of the square, our x squared can leave the house. So radical x cubed is the same as x square root of x. And then let's just block this off. Radical y squared, well, we know it's a perfect square, so that leaves is just y. So now we have that the 800 comes out as 20, and then inside our radical house we have 2. The x cubed comes out as x, and inside the radical house we're left with another x. And then the y comes out as just y, because we don't have anything left over. So the square root of 800 x cubed y squared can be simplified to 20xy radical 2x. So remember, when you're reducing radicals, it's okay to start at a smaller number and work your way up. Sometimes steps are the easiest way to go, and they avoid the most mistakes. It's also helpful to list all of your perfect squares so that you have something to reference, at least until you get the real hang of it. I hope this video helped. Good luck!